Assalamu alaikum. My name is Hira Zamir. I'm from MS Chemistry Department in University of Management and Technology. Here I'm going to present about the reactor, which is the suspended bed reactors. The suspended bed reactors, which is also called fluidized bed reactors, are used into the chemical reaction that involves mixing of solid particles with liquid or gas reactants to carry out the reactions. So, if we have to deal with the solid particles to make it react with the liquid or gas, we use these suspended bed reactors. This is the simplest form of the suspended bed reactors in which we inlet the solid and gas material. Solid is added from the ups down and gas is injected from the down to upside. There is a gas bubbles created and mixing of the solid and gases or liquid happen. Extra gas is evacuated and we obtain our product. What are the principle of suspended bed reactors? When a fluid streams, that is either gas or the liquid, is passed through a bed of granular materials, the velocity of the stream is gradually increased and reached to the point where drag forces resisting the flow of fluid is equal to the weight of particle in the bed. Further increase in the fluid velocity would lead to the expansion of the bed. That is, the particles are separating, resulting in the greater area for the passage of the fluid. Then this limits the pressure drop across the bed. This condition corresponds to the limit of stability of a packed bed and makes the transition to the fluidized or suspended state. This is how this that is the main principle. This is how the mixing takes place. But if the fluid velocity is held constant at this point, the force of the fluid balances the weight of the particle, and contact among particles tend to the cease. The surface of the bed adjusts itself like a liquid, and the particles will remain suspended as long as the fluid flows at that velocity. As the fluid velocity is still increased, an intensive mixing of the bed begins, and finally, on increasing the gas velocity still more, carry out of particles from the container occurs. A fluidized condition exists for only a specific range of the fluid velocities. Below this range, the bed is stationary or fixed, but above it, the particles would be transported out of the bed. In the fluidized regime, the bed is expanded to the volume that is greater than the fixed bed, and particles are in a continuous oscillations that colliding with one another and moving from point to point within the bed. This is the inlet gas bubble phase and emulsion phases, fluidized bed reactors. And in these back reactors is present emulsion phase is bubble phase. Key feature of the suspended bed reactors, the catalytic reaction. These reactors are most commonly used into the catalytical reactions in which this reactor provides the large surface area to the solid particles so the desired reaction can be achieved. Liquid solid reaction. The overall flow pattern depends upon the fluid medium and the size, shape and density of the particle being fluidized. Particulate fluidization refers to the bed expansion under uniform distribution. Particulate fluidization occurs with the liquid solid system and gas solid system when the particles are very fine. It also helps into the gas solid reactions. Aggregative fluidization is regarded as an excess of fluid passing through the bed in the form of the bubbles, giving rise to the essentially a two-phase systems. Aggregative fluidizations occur with the gas solid system and sometimes with the liquid solid system when the solids are of high density. Velocity of fluid The suspended velocity, that is the terminal velocity, and the prosperity of the bed. The superficial velocity is defined as the velocity that the fluid would have if there was no particles. That is their superficial velocity of the fluid. The velocity of the fluid before entering the bed. The terminal velocity is the velocity of the free falling particles in the medium. The prosperity or the void fraction is regarded as the ratio of the volume of the fluid and the total volume of the bed. Control resistance time. The resistance time of a particle in a reactor can be controlled by adjusting flow rates of gas and liquid, allowing full control on a reaction kinetics. This is our simplest form of the suspended bed reactors, in which the diffuser is present, air is injected through flow meter and passed through the filter and fed into the reactor, in which that is the fluidized bed reactors, which is also called the suspended bed reactors. Immobilized cells are present, gas beads are present, and after the reaction takes place, it is going through the pump and we obtain our product. Application of suspended bed reactors. One of the most important is biological phenol removal using the suspended bed reactors. Phenol and phenolic compounds are very common. Of the effluents from the industrial processes included oil refineries, pharmaceutical plants, ceramics, steel plants, coal, conveyance processes, and pharmaceutical companies, wastewater containing the phenols and other toxic compounds that require the careful treatment before discharge into the receiving water body. Phenol is a troublesome that contain very toxic material that cause the irritation to the skin. It also contribute to the off flavors in drinking and food processing. In this air pump, air filter is used, mass is transferred into the mixing chamber, and then it is fed into the suspended bacterias. After that, the nutrient solution is injected or it contains the drain port. The reactor consisted of a column packed with the volatile beads. We use the bed bioreactors with activated carbon and calcium and compared phenol degradation between free and calcium and gel immobilized system. Then immobilized cells onto the polyacrylamide gel beds. While other method is to immobilize cells or other materials. Another method is to use fluidized bed reactors where mixed culture of the phenol degrading bacteria is immobilized on the particle. First one, in this we use the carbon or the calcium, and the other method is we using the bacteria itself as the catalyst which is degrading onto the particles, immobilized onto the particles. The other application is gasification. The suspended bed reactors are also used in gasification of solid carbonaceous material such as coal and biomass to produce synthesis gas for many applications, including power generation and chemical production.